All right, here we go. Our standard for today, we're looking at algebra, creating equations, and creating equations to describe numbers of relations. However, standard two of that is creating equations in two variables, two or more variables. Today we're going to do solving for a particular variable. And like I was mentioning earlier, today will be that first true lesson on algebra, because we're going to be looking at equations that do not have any numbers. So today you need to trust your instincts. All the processes that we've learned so far, you need to make sure that you whatever you're thinking, try and apply to what we do, because it is going to work. But some of you, since you don't see any numbers, you might think maybe it does not work. No, it does. You already know the steps. So we're going to continue and find out how that's going to work. So check this out. We're also going to be looking at attending to precision still, right? And also math practice standard number 7, which is looking for structure. We still are going to make connections between numbers and areas and tiles and as much geometry we can embed. Okay? So with that said, our objective for today, I can solve two variable equations. Let's read it together. 1, 2, 3. I can solve two variable. So, before I continue, let me just map you so far where we've been. Okay, here we go. We started the year, I'm going to start from the top. We started the year with real numbers. We did addition, subtraction, multiplication, and division. Remember that? I even introduced you from the very beginning. I did a video of the planting of the rosemary bush. Remember that? For the ground zero. Okay, and then we did addition and subtraction using 4 different methods, and then from there we got into multiplication and division, and everybody was happy. And then all of a sudden, we get into powers. And all of a sudden, some of you started like, whoa, what's going on with all these exponential rules? Remember that? And from there, to top it off, we continued with polynomials. Remember that? And I said, guys, polynomials, ever since now, they're not going to leave anymore. You go to Donut Avenue, turn the corner, and who's there? Dun, dun, dun. Polynomials. They're not going to leave. Okay? From there, we covered expressions. And I remember when I did the formal introduction to expressions, I remember that we went to a concert. Remember that whole idea about the concert, and then there was country music, and then hip-hop, and so on and so forth? We did the differentiation of 2 types of expressions, algebraic and numeric. From there, I said no more expressions. We're looking at one variable, equations. That's when we started solving equations in one variable. Then we did multi-step, we did absolute values, and all this and that, right? And from there I said, well, guess what? Now that we finished with equations, we're going to finish up now with inequalities. And guess what? Notice that we did for equations and inequalities, we did one variable. However, we arrive now at this point. 2 variable. So we're done with the easy stuff. The rest was easy. Now we're getting into the rigorous stuff, okay? So like I said, today will be the first lesson that we're going to start seeing some of the stuff that we need to trust a lot on the steps that we already practiced, okay? So with that said, what kind of 2 variable stuff are we going to look at? Well, before that, let's clarify what 2 variable equations are. You have the prayer model, right? Copy this down, please. 2 variable equations. Instead of copying all the definitions, just copy what I underlined. What are 2 variable equations? 2 expressions equal to each other, comma, and contain 2 unknown variables. 2 expressions equal to each other and contain 2 unknown variables. 2 expressions equal to each other and contain 2 unknown variables. 2 expressions equal to each other and contain 2 unknown variables. 2 expressions equal to each other and contain 2 unknown variables. 2 expressions equal to each other and contain 2 unknown variables. 2 expressions equal to each other and contain 2 unknown variables. Yeah. 2 expressions equal to each other and contain 2 unknown variables. two expressions equal to each other and contain two unknown variables. Okay, we got that, right? Let me give you some examples. Write these down, please. Examples. 3x plus 6 equals 3y. 12x equals 4y minus 8. 2a plus 2b equals 14. Negative 3n equals m minus 6. And y equals x squared minus 9. Copy that, please. Pens down. The definition says two expressions equal to each other and two unknown variables. So let's see. Look at this first one. Here's an expression, and the equal sign means that they're equal to one another. Do they have two different variables? Yes, x and y, different variables. Okay. 12x is one expression, 4y minus 8 is another. Are they equal to each other? Yes. Two different variables? Yes. 2a plus 2b equals, or actually this is an expression, this is an expression. Are they equal to one another? Yes. Two different variables? Yes. Same here, same here. Are we there so far? Look at the none examples. Look at those. Okay. So this one particularly, think about it. Why is that a none example? Look at this one and look at this one. I gave you the definition and I gave you the examples. Think about it. All right. Talk it over with your neighbor and I'm going to call on somebody. All right. So the most important thing to remember about equations, they need to have what? An equal sign and two variables. Write that down, please. Have equal signs and two unknown variables. Equal sign and two unknown variables. Okay? Copy that, please. All right. So now that we have the definition for two variable equations, we need steps. Right underneath that, I want you to write steps, and we only need two steps. However, we already know them, so think about it, don't say it out loud. When we solved the equations and inequalities, we had 4 basic steps. Don't say it out loud. Okay? But today, we're only going to use the top two, the first two. Write the 2 keywords on your paper. See if you can remember. Write those down. Okay? So by now, you should have written, number 1, simplify. Number 2, isolate. Remember? The 4 steps for equations and inequalities were simplify, isolate, plot, and check. The only thing for today, we're not going to use the plot or the check. Only simplify and isolate. Okay? So therefore, write your keyword, simplify, isolate. Just to double check to make sure everybody understands what we're looking at. When we simplify each side, pretty much we start with grouping symbols, we get rid of grouping symbols, and we combine like terms. When we isolate the variable, that means we use inverse operations to get rid of anything that's around the variable to leave it by itself. We already covered that, right? Yeah. Okay. However, today we're going to be looking at certain type of equations. There's a couple that I need to cover. The first one, we're going to be looking at formulas. So check this out. What are formulas? Formulas are equations that give a rule. Now, some of you that already started some of this work in science, and I also have given you some rate problems, you already use the formula D equals RT. Who's heard of that one before? Distance equals rate times time. If not, the rest of the year, some of you are going to be using this a lot with your science class. However, in this case, notice that the D is by itself, right? That's what we call that D is isolated. D is by itself. However, if I was to ask you to solve for a different variable, what that's called, it's called solving for a variable. So check this out. How does that work? Let me show you. We have D equals RT. Don't copy this. You're just paying attention. And let's say I want it, and I ask you, here's the formula, and I want you to solve for R. And you're saying, wait a minute, there's no numbers now. Exactly. This is what we call algebra. There's no numbers. All it is processes. You know the process. Here we go. I'm looking at R. I need to solve for R here. So by looking at it, R is on this side of the equation. What's next to it? T. And what operation is between the R and the T? Multiplication. So how do we cancel that t? Divide by t, and whatever we do to one side, we do to the other. T over t is 1. 1 times r is r. What's left over here? D divided by t. That's what we mean by solving for a variable. Everybody see that? Notice that the process is the same, but are we using numbers? No. Now we're using variables. Everybody got it? Okay, so now we got that so far. So we're going to be looking at formulas. However, notice that this is not a two-variable equation. Does everybody see that? This is a three-variable equation. Any equation that has more than two variables has a particular name. Check this out. The name of that equation is a literal equation. An equation that has more than two variables is a literal equation. On the left side of the Q, write that down. Literal equation. On the left side. Literal equation. Equation with, bless you, with two or more variables. Literal equation, an equation with two or more variables. Literal equation, an equation with two or more variables. Literal equation, an equation with two or more variables. So, we got literal equations. All right, here we go. So, copy this down and copy them side by side. Example 1A and 1B. 1A and 1B. If it doesn't fit underneath the steps, then copy this in the back. Example 1A and 1B, and it says, solve x plus y equals 15 for x. And the other one is solve pq equals x for q. Copy those, please, and then we'll do these together. Pay attention. First steps first. We see that it's an equation, so automatically I draw my line down the equal sign. You're just paying attention. Don't write anything down. Here it goes. Second. I know. Pens down, please. Pay attention. Here we go. So, the first thing I do is identify what variable they want me to solve for. Therefore, I'm going to circle that so that I know what I'm looking for. What am I looking for? X. I look at my equation. I have two sides. Everybody look up to the screen. This side and this side. Where is X? On the left side, okay? To leave it by itself, what's around it? The plus y. So how can we get rid of that plus y? Minus y, minus y. So this is, we bring down the x equals negative y. This is a positive 15, and I'm done. Or I can write it like this. X equals, I can write the 15 first and the negative y after. These two would be, any of these will be the answer. Copy that, please. All right, here we go. Let's do this one together. First of all, we have PQ equals X. Are we there? Okay, draw your line down the equal sign, so like that we can see which side is which. And then you're going to circle whatever they're asking you to find. What are they asking us to find for? For Q, okay? So that's going to make us focus on our equation. So where's Q? It's on the left side, okay? To leave Q by itself, what's next to it? P. What operation is happening when they're side by side? Multiplication. That means the inverse is to divide by P. Divide by P. We're left with Q equals X divided by P. And we're done. Copy this one. Example, I think it's 2 or 1. So let's see. Example 2. We have solve 5 minus b equals 2t, and we're going to solve for t. See if you can do this one by yourself. Go. 30 seconds. Here goes the process to see if you did this. First thing that you should have done, line down the equal sign. Second thing, you circle whatever they're asking you for t, okay? Where's t at? It's on this side. What's next to t? The 2. What is happening here? Multiplication. So what is the opposite of multiplication? We get rid of 2 by dividing by 2. Dividing by 2. Since we're solving for t, that means we need to leave t by itself. We need to get rid of everything else. So this is T, let's see, over here we're left with 5 minus B over 2 equals to T, and we're done. Now, some of you might have gone one step further. What is 5 divided by 2? 2.5 minus, we're left with B over 2 equals T. Either one of these is correct. Copy this next one down, example 3. Example 3, solve D equals M divided by V for V. Copy that, we'll do that one together. There it goes. Line down your equal sign, circle whatever they're asking us to solve, V. Oh, all right, pay attention, here we go. We need to solve for V, but in this case, V is the one that's dividing M. So how can we get rid of M? Now, earlier, check this out. Somebody said this. They're like, I have D equals M over V. Somebody said, well, multiply times M. Let's see. So check this out. Look what this does. What is M times M? So therefore, that does not do the trick. So therefore, check this out. So what we're going to do, we're going to get rid of the V, send it to the other side, so like that we end up sending D back. So check this out. How do we get rid of V if V is dividing? What is the inverse? Multiply times V, multiply times V. Check this out. We're left with V times D equals M. So therefore, what do we have here? Multiplication to get rid of the D, because we're solving for V, right? What do? Divide by D, divide by D. Therefore, we're left with V equals M over D. Copy that. Now I'm going to give you one just like it to see if how you do by yourself. Okay, as you're finishing that, I'm going to give you another one. This is example 3Q. P equals Q over R. And I want you to solve for R. Solve for R. Go. Okay, line down the equal sign. We're going to solve for R. That means I need to multiply times R. Multiply times R. This becomes RP equals Q. To leave the R by itself, I need to divide by P, divide by P. Therefore, R equals Q divided by P. Hands if you got that? Okay. So now, just remember, that's going to work exactly the steps like that only when the variable that we need to solve for is actually dividing another variable. Okay? Because if we were to solve for M in this case, we would just get rid of the V and we would be done, right? But that's not the case. Okay. Copy this one, example 4. Example 4. It says, solving formulas. Here they're going to give us the formula for the triangle. So just copy this formula. A equals 1/2 BH. Copy that. And they want us to solve for H. So copy this formula and then write solve for H. Example 4. Copy that, and then we'll go over it together. Line down the equal sign. There it is. And then I'm going to circle which variable they're asking us to solve, H. That means I need to leave H by itself and get rid of everything else. This one does have a number. It's a 1/2. When we solved the equations, I showed you how to get rid of a fraction, didn't I? You multiply times the reciprocal, 2 over 1. Whatever we do to one side, do to the other. So therefore, this is a giant 1. 1 times BH, that is BH. 2 times A, that's 2A over 1, which is 2A. Are we there so far? Are we done solving for H? No. What's next to the H? The B, and it's multiplying, so therefore we need to divide by B. Divide by B. So we're left with 2A over B equals H. Hands if you got that. Okay, yes. Okay, let's go to the next one. Example number 5. Copy the formula. Example 5. Solve the formula for a person's typing speed for E. So it's S equals W minus 10E over M. Okay? Over M. Okay, yeah, let's do this one together. Here we go. Yeah, line down the equal sign. They want us to solve for E. So this side, E is right here, but what's here stopping us from doing everything else? The M. What is the M doing? So therefore we need to multiply times M, multiply times M. We're done with that. We got MS equals W minus 10E. Are we there so far? Yeah. So, what did I say when you have a variable and a number with a negative sign? You circle that because that's all together. So to leave that by itself, what's next to it? How do we get rid of it? Subtract W. Subtract W. We're left with MS minus W equals negative 10E. Is E by itself? No. No, what's next to it? The negative, this is S. It's negative 10, right? So therefore, if the negative 10 is multiplying, we need to divide by negative 10, divide by negative 10. We're left with MS minus W divided by negative 10 equals E. And we're done. Yes, it is. Okay. How are we doing? All right? Okay. Okay, let's do another one. Copy this one down. Example number 6. Example 6 says, the formula for an object's final velocity is F equals I minus GT, where I is the object's initial velocity and G is the acceleration due to gravity, and T is time. Solve for I. Okay, so let's do this one together. I got F equals I minus GT, and we're solving for I. Okay, so let's see. Line down the equal sign. We need to leave I by itself. What's next to it? Minus GT. So how do we get rid of that? Add GT. Add GT. This cancels. We're left with F plus GT equals I. And we're done. Everybody see that? Okay. Now, before you close, well, as you're finishing up, check this out. Let me show you the next one, which all it is they're just going to substitute one value in it. Check this out. Look at this one. On this one, they give us one with a circumference. Circumference equals pi times diameter. However, in this case, they do give us a value for the circumference. What is the value that they give us? So this becomes 18 equals pi times d. And the question is, what is the bowl's diameter? What variable should we solve for? If they're asking for the diameter. D. So what's next to d? Pi. And what operation is happening in between? Multiplication. So we divide by pi. Divide by pi. Check this out. We're left with 18 over pi equals d. Everybody see that? Okay, homework. Before you leave, have a seat, please. Homework. Pages 111, 112, numbers 2 to 30, even. Okay? So, all right, there's tutoring today, and if I don't see you in tutoring, see you guys tomorrow. Enjoy your homework, guys. Bye. No.